Alright, 17. The way they want you to graph this is by plugging in numbers. It says by a table, right? So a table looks like this, where you have X and you have Y. Okay? So you'll plug in, let's say you plug in 1, right? What's 1 squared? 1 squared. 1. Negative 1, right? Because it becomes negative. And then negative 1 to plus 4 is 3. And then let's plug in a 0. Okay? A 0. And a 0 squared is 0, right? And 0 plus 4 is 4. Okay? And then let's plug in a negative 1. A negative 1 squared would be 1, right? But it still becomes negative because the negative's outside the square. Remember, this negative is not affected by that square. This negative is, because that would be negative 1 squared negative, which becomes 1 negative plus 4, which is equal to 3 again, okay? And then they want you to graph that. Okay? So they want you to graph it, and it goes at 1 and negative 1, right? It's going to be at 1, 2, 3, 4. Okay? So at 0, we're at 4. At 1, we're at 3. At negative 1, we're at 3. So what's happening here is this. What happened there? What is this? As far as what's the parent function?
X squared.
X squared. So is that a quadratic, cubic, quartic, quadratic? So we know from our last chapter is that this is a quadratic, right? And it should look like this, right? And it's f of x equals x squared, right? If we think about that, that would mean it'd look like this. But it doesn't look like that. It looks like that flipped and moved. Right? What flipped it? What moved it? Right? Do you remember when we were moving things? When we said the whole function? If the whole function was added, it would go up 4.
Well, if we do it H and K, you find vertex, and then it depends on what's in front of the x squared. If it's a negative, it's going down. If it's positive, it's going up.
Yep.
And if it's adding, you're going to be up on the y-axis versus subtracting, which would be down on the y-axis.
Yes. So, but we haven't learned the HK yet.
I did not get a word you said.
Okay? We haven't learned the HK yet, but what we have learned is the whole function plus the whole function, this whole function, plus a number pushes it up, right? That's what we did, right? If we said go up, you said plus 4. If we said up 4, the vertical up 4, right? You would go plus 4 to the whole function. Is that right? And that's what's happening here. It's going vertical up 4. But then, what happened? It got flipped. Why did it get flipped?
The negative in front.
That negative in front flips it. Okay? So we haven't talked too much. We talked a little bit at the beginning, and then we didn't really test you on flipping yet. This week, we're going to be testing you on flipping. It's okay.
I don't do gymnastics.
Okay? You will in here. It's fun. And in here, it's a lot easier. You might hit your head, but you don't get a concussion. It's great. All right. It feels like a concussion because when you got new axioms in your brain forming, it hurts. You get headaches. But it's actually good for you. All right. So that's kind of where we're going today and tomorrow. Okay? So we're going to be able to move this and flip it. This one, I don't really like this one because it's not in the vertex formula, right? We're going to be able to do this, okay? We're going to be able to say, eventually, next week, I'm going to, yeah.
I'm gonna keep talking.
Okay, so next week, I'm going to teach you how to do this, where you're going to say f prime of x is equal to 4x plus 4 equals 0. Solve it so that x equals negative 1. That's your axis of symmetry, right? That would be your axis of sim. And then you'll plug that in, right? You'll plug it back into this, and you'll go negative 1 squared is 1, times 2 is 2, negative 1 times 4, negative 4 minus 1, that would be negative 2 minus 1, that would be negative 3. So that means my vertex is at here. That's my vertex. Okay? And from there, I can graph it, plug in a 0, boom, that's going to be at f of 0 and negative 1. So I'll be able to graph that point. So now I have negative 1 and negative 1, 2, 3, and then negative 1 and 0. And it'll look like this, and then I'll go same distance away from that, so it'll be right here, and it'll look like this. Boom. And that's what we're going to do next week. Okay? Looks fast, looks hard,
I want to kick you in the face.
right? But it's not bad. It's not bad. What you're going to do this week, and I did that in orange because it's just kind of setting it. You don't have, you can copy it if you want, you can take a picture, but don't worry, it's not going to make any sense until I show you the steps. I'm just kind of showing you where we're going, okay? This week, what we're doing is just plugging in some numbers. Tell me where it's going, right? So you should be able to plug in some numbers. What are some good numbers to use here? So since I already gave you some good numbers, right? A good number would be 0, right? Negative 1 and negative 2. Those would be the perfect numbers, since I already showed them to you. Now, you're not going to know those perfect numbers, so the book wants you to try out numbers until you can figure out the pattern. I'll show you what it means. Normally, we go 1 and 0 and 1. That's our x's. Right? And then we try to figure out what our y's are going to be. And what's 1? So I plug in 1, and that'll be what? 2? Right? And then, what's 1 times 4? It would be 4 minus 1. So that'd be 6 minus 1, which is 5. Is that right?
Yep.
Okay.
So, question?
Now, what about 0? If I plug in 0, then that's 0, that's negative 1, right? Does that make sense? Like 0 is going to be our fun number to plug in because it gets rid of everything. Does that make sense? How are we on that one? We're just plugging in numbers. Kinda. Okay. 0 times 0 is 0. 0 times 2 is 0. 0 times 4 is 0. 0 plus 0 is 0. So it's always going to be that last number. If there's x's, the x's go away whenever you plug in 0, and whatever number is there, that's what it becomes. Okay? So, but what happened? Yeah, question?
On this side, is it always 1, 0, negative 1?
Those are the numbers I like to start with. If you're just trying out some things, right? Eventually, we'll get smarter. We're going to learn this little vertex formula, and we'll get a little smarter at what we can do.
Oh, I know what that is.
Okay? And then eventually, too, we're going to learn what's called the derivative. I'm going to show you that. We're going to be able to do this. If you had me for Algebra 1, who had me for Algebra 1? Right? You should have learned the derivative, right? Right? We taught it. You don't remember it because it was 2 years ago, right? But we taught it. The derivative. Remember when we were doing this? If we have x cubed, we said plus 2x squared plus x, right? We said what's 3 times 2? 6. 2 times 2 is 4. Take 1 away, take 1 away. 1 times 1 And now we got a cubic turned into a quadratic. 2 times 6, 12. 1 times 4, 4. This is what we call the derivative. Okay? We're deriving something from this. But if you didn't have me, you didn't learn that. So how many of you learned this? 2ax plus b.
Maybe.
Okay? That's the derivative. Think about it. If you have ax squared plus bx plus c, right? That's your quadratic. Right? Take the derivative. What's 2 times a? 2a. What's 1 from 2? 1. So 2ax and then plus b. And then when you take 1 away from that, that's x to the 0. The x to the 0 is just 1, and it goes away. And so this and this are the same thing. The derivative is the formula that they give you. I just show you how to derive it. Okay? So that you can do it not only with cubics or quadratics, but with cubics. Okay? It becomes really helpful later. Okay? But that's next week. That's next week. This week is just about plugging in some simple numbers. Okay? So we plug in 1, we plug in 0, we plug in negative 1. If we plug in negative 1, I get negative 1 squared, which is 1, right? Okay? That's 2 times 1, which is 2. Negative 1 times 4. Negative 4 and negative 1. And so what do we get? We get 2 minus 4, which is minus 2 minus 1, which is negative 3. And so we plot these numbers. Okay? And we would plot these, right? We would plot these 1, 0, and 1. Negative 1, right? Okay? And so we'll do the brown one. That's 1, 2, 3, 4, and 5. Okay? We'll do the 0 that was purple at negative 1. And then at negative 3. Okay? And so what we're seeing, right? And we don't know, is it going to turn back up or is it going to keep going down? We don't know, right? So we would plot the next number. Okay? So then you would plot this next number in. What's the next number you would plot?
Negative 2.
Negative 2. Okay? And so when I plot in negative 2, what happens? Well, negative 2 squared is 4. Times 2 is 8. Negative 2 times 4 is? Negative 8.
Why did you add more?
Huh?
Why did you add the negative 2?
I'm plugging it in here.
I know, but why did you add the negative 2 to the
Because we don't have a graph yet.
You have to keep doing it until you do it?
Yeah.
That's annoying.
Where's 0,
Yes.
negative 1 at?
Huh?
So where's 0, negative 1 at?
0, negative 1. 0, negative 1. So 0 on the x and down negative 1 on the y. Does that make sense? So good question. So the question was, where's 0, negative 1? Because a lot of you are going to be having trouble with graphing because you might not have did it last year. Or you don't remember it. Right? The brown one, what's that one? That was 1 and what? Went up 5. Good. Okay, those are your coordinates. This is huge. If you don't understand where the coordinates are, we're going to have lots of problems. Yes. So the next one, we found, what does that say? That goes to negative 1, right? So that's 8 minus 8, which is 0. And you get negative 1. So when f of negative 2 is equal to negative 1. And that's what happens here. That's what x is negative 2. I'm plugging it in, and I'm getting y. F of x is equal to y. We have to know that by now. And if we don't, we have to learn it right now. Because this is huge, this chapter. Okay? So, now I know if I plug in a 2, I have -1, and I should be able to graph that. -2, right? -1, and then what you should see is this thing starting to form, right? And now we know it's a quadratic. Did we know it was a quadratic already? Yes. We should know it's smiling from when we first talked at the beginning of the year because it's positive. We should know this is frowning because it's negative. Does that make sense? So those are some things we're going to have to know just by looking at it. 1, it's a quadratic because it has a 2 as an exponent. 2, it smiles or it frowns. We should just know that every time. Okay? Smiles, right? It smiles because it's positive. Okay? It frowns because it's negative. Okay? It's that simple. Okay? We should know that. If it's negative out front, not here, we don't care about this. We care about out front. If it's negative, it frowns. If it's positive, it smiles. It's a cup. It opens up. Okay? Good. I'm going to let you guys get caught up on that.